Hi, my name's Elesey, and this is a video on my senior learning project, NOCTEM. It's an infrared thermal camera device. And I agree for this video to be publicly available. With this project, I wanted to dive into the world of thermal camera devices. With the little that I knew before starting this project, I realized that the camera devices are generally expensive and the resolution is very, very poor. You're usually looking at maybe like 40 by 40 pixels when most cameras, are shooting 4K or even 6K, things like that. So I was curious as to why the devices were like that and if there was a way to increase the resolution and keep costs fairly low. My initial idea for this project was to use two sensors and have them close enough together to where they can take a frame together at the same time, but then you could combine the information from both sensors and essentially double the resolution. However, as this project kept going and progressing, I found it more and more difficult to essentially just start working on the sensor. As the project progressed, I realized I may have been a little too ambitious when I wanted to have the two sensor setup. It was a lot more difficult to even get a single sensor to output and read data from it. Now, it wasn't necessarily difficult to read the data from it. It was finding a way to take that data and get it to a display. That took learning several different programs, multiple different chips, and essentially boards like Raspberry Pi, Arduino, and just some kind of off-brand board in the beginning. At first, I decided to go with the thermal camera kit. It comes with a sensor, a little board, and a display. And as you can see, it is working. It should show it's roughly 30 degrees Celsius. Now, I did have a lot of struggles with this board. I was hoping at first that I could use the USB-C output on here to grab the data from the device and stream it directly to my computer, which is much stronger than the little chip here, and do more manipulation with the data that I get. I was even thinking that I could possibly grab a secondary sensor and combine the two and process the data at a high resolution. However, as I tried to mess around with this, it became more and more apparent that I needed a different type of chip. My first idea was to use the Arduino Due because, as I read, it was much more powerful, has essentially a ARM processor on it that works well enough that it should be able to complete this task. Now, this is the little board right here. Now, with it, I did end up still having issues. What I decided to do was just salvage the sensor from this chip. Just pulled it off. I used a proto board and I simply wired the Arduino Due to the pinout. Now, using this, it was really interesting because the Arduino Due, it has its own software that you have to use. I think you write in C or something like that. I'm not too certain. But when I would write code for this little chip, I'd have to use drivers that are designed for it. I'd have to pull them from GitHub. And there's different versions of the drivers for this chip. I initially started out using, later I found out that there are old versions of it. And afterwards, I had a lot of trouble trying to salvage the code to get it to work with this. And after looking at a lot of forums online, it seemed like that was a common issue. Something with the drivers on it with Arduino Due, it was becoming incompatible with the Arduino Due and the sensor. So I ended up having to look up a new device or something else that could maybe fix this. I was thinking maybe I could use a new sensor. I could use maybe a different way of wiring it to the Arduino Due. After looking at a lot of stuff, it seemed like the easiest solution was actually to just get a Raspberry Pi, and that's what I did. This is the Raspberry Pi 4. It's the 4 GB model. It's running essentially Ubuntu. With this, it actually was quite easy to get it working. For one, I had to write in Python, much easier than writing in C. And it was the only issue. I had to solder some wires to this thing because I didn't have the little female connectors. But once I got it up and running, it worked surprisingly well. And now it seems far more attainable to possibly use two of these sensors and double the resolution. Now I could show you an example in a little bit. It'll probably be recording on my screen where it walks through how this device is set up and how it works. So this is the IR camera running on the Raspberry Pi using Python. It's also using PyQt to display the image directly in Linux. So now that I got the Raspberry Pi working and with PyQt and running on Python, it's been great. It's a lot easier to work with, making changes, updates, and stuff like that. Also, it's nicer working within Linux because I could just make changes and test it right away instead of having to upload things to the Arduino. So it's been a little bit easier. However, I've ran into a new issue actually while filming the video. While moving the wires around, I must have messed something up and I'm having issues with the sensor. So it shows how finicky it is. I think it's something to do with me soldering the wires instead of using male to female adapters. But that's something I could fix in the future. After having filmed that little section, I decided to mess around with some more, and it does seem to be working on the sensor. Here is the PyQt, and it's running the thermal camera. And as you can see on the screen, it is showing a reading right now. It's 25.2. And if I put my hand over it in a second, it'll update. It's going 32, and it should be able to see the hand outline. So yeah, however, I do need to fix the refresh rate now. It's something that I had to manipulate to get it to work properly. But yeah, there we go. And it's been really finicky. It's something with the wiring. As I was messing around with it, I had to lower the refresh rate and then mess around with the wires here to get it to work properly. However, while I wasn't necessarily able to get two sensors working how I originally planned, that's mostly due to going down the wrong paths initially and not knowing exactly what I needed to be able to get it to work. Starting out with a regular microchip that essentially I can't pull data from, going with the Arduino Duet, which has issues of its own working with this sensor, and finally settling on a solution that works with the Raspberry Pi using easy to learn code, Python. It's a little too late. It's taken too long to get to this point. I've now realized that how much more important it is to do research not only on what you could possibly use for a project, but maybe what people have done and see if there are any issues with those setups, or look into those kind of areas, because it's easier to just find a thing and be like, oh hey, this works, I'll try to develop it like this because it seems like other people have done it and it works. But you don't really look into, hey, what kind of issues are people having with this system? Is it possible that I will have the same issues? It's kind of easy to overlook these things, and if I hadn't overlooked them and looked at all these issues that were happening with Arduino Duet, or I could have right away hopped onto the Raspberry Pi, had the right connectors and everything, so I wouldn't be having this issue right now where it's having issues detecting the sensor. It would have been smoother and I could have been much further along the project than just simply getting it up off the ground at this point. So a lot of rough lessons learned, and hopefully you guys enjoyed this video, me discussing my project, and thank you.